Okay, guys, here is our 7.3 practice, which is going to get you ready for your test, which is next Monday and Tuesday. It's going to be 6.6 law of cosines and the 7.3 graphing trig functions. So what I want you guys to get focused on is to identify the transformations that are happening within the function equation. You're going to pick the graph from four matching questions. So I want you guys to focus on identifying what transformations are happening, and then you can match those things to the graph. So if I look at number one, right here, this 3 in front is my amplitude. This is how tall, how high, and how low my graph is going to go. All right. Do I have any shifts up and down? No, I don't have anything in the front that's plus or minus, and nothing in the back. So you're looking for a graph that is going to start around or on the x-axis. Since this is a sine curve, it's going to start at the axis, and the highest point it's going to go is +3. The lowest point it's going to go is -3. The time period is this number right here in front of theta, so it's just going to be 2 pi. So you're looking from 0 to 2 pi. And this right here is telling you it's going to shift right 5 pi over 6 units. This is you showing me your work, because you're going to pick the graph that matches this. But when you go through and I say I need to see your work, this is your work. You're identifying all of the attributes that the graph has, so then now you can pick it. You're looking for a sine curve, so it starts at the x-axis, that is shifted to the right 5 pi over 6 units for a time period of 2 pi, and the amplitude is up and down 3 units, okay? Same thing here. I'm going to start off and I'm going to say, okay, what's going on? Is this graph shifted left or right at all? No. So it's just going to start right here at the amplitude. It's going to start at the amplitude since it's a cosine graph, okay? So amplitude. The highest it goes is 3. The lowest it goes is 3. And my time period is 2 pi over 1. So you're looking for a graph that starts at +3. The highest and lowest that it goes is 3 and -3, and it's going to be over the span of 0 to 2 pi. So if you were looking for something, it would just be here. It starts at 3, 0, at the x-axis, down to 3, back to the x-axis, and then, up to 3. Okay, very simple, guys. So looking here, there's no graph to look at. All I want you to do is just practice the transformations, identifying. So first things first, cosine. It starts at amplitude. Look for shifts. Does this graph shift up, down, left, or right? Does not go up and down, but it does go left 5 pi over 6. I say here, oh, this is my amplitude. The highest the graph goes is 5. The lowest the graph goes is -5. And my time period is this number right here in front of theta. So it's 2 pi over 1, which is 2 pi. So you're going to find a graph that starts at +5. It goes over the span of 0 to 2 pi. But where is it shifted? It's shifted left 5 pi over 6 units. So you can pick that out visually from your graph. Same thing here. I have a sine curve. So this is going to start at the x-axis. All right. This +5 right here, it's a 5 plus in the front. This is a vertical shift up 5. So you're looking for a graph that shifted up 5 units. It's also going to move left 3 pi over 4. Remember, it's the opposite of what you think if it's inside the parenthesis. And my time period is going to change here. This 8 right here, I take my 2 pi and I divide it by 8. So the time period that we're talking about is just pi over 4. So you would look for a graph that is shifted up 5, left 3 pi over 4, and the time period is truncated, it's shortened. So you guys should be able to pick a graph out knowing all of these attributes. That's what I'm telling you. You don't have to stress over how to exactly graph since it's matching. Look here. First thing I see is there is a vertical shift down 2 units. And I see that there is a horizontal shift right pi over 6. So look at your graph choices. Is there a graph that shifted down 2 and right 6? If there's 1, that's your answer. If there's 2, then you go to look and say, okay, Well, my time period is just going to be 2 pi, and it's a sine curve, so it's going to start at the x-axis. Okay, that's important that you guys can pick these things out. And again, by you pointing to everything that's going on inside your equation, that is you showing your work. Tangent, don't worry about it. We're only doing sine and cosine in this section. All right, so right, that was everything on there. Yeah, go to the next page. Okay, so let's look here. First thing I see is that it's sine. We're going to start at the x-axis. So at x-axis. Do you guys see plus or minus at the beginning or the end? No. Do you guys see a parenthesis where things are moving left and right? No. So you know that this graph is going to start at the x-axis at 0, 0. What is my amplitude? Well, the highest it goes is 1. The lowest it goes is -1. That's right in front. The only thing that's a little different here is our time period. Our time period is 2 pi divided by that 3. So my time period is 2 pi over 3. So you're looking for a normal sine curve that highest it goes is 1, lowest it goes is 1, and it's just over the time period of 0 to 2 pi over 3. Here, do I have anything shifted left, right, up, or down? No, I don't. So that's good. We can see we don't have anything shifted from the x-axis. Since this is cosine, I know it's going to start at the amplitude. And what is the amplitude here? It's positive 1/2. That means it's going to start at 1/2. The lowest it's going to go is -1/2. The thing that's a little different here I can look at is my time period. My time period is going to be 2 pi over 4, which gives me pi over 2. So my whole graph is going to span between 0 and pi over 2. I'm looking for a cosine graph, so it's going to start at the amplitude. And the highest it goes is positive 1/2, the lowest it goes is negative. So if it's going to start here at positive 1/2 and it's going to end here at pi over 2, it should look something like this. A little skinny thing right here. If it's pulled apart and pi over 2 is the last one over here, then it's just going to be a nice little skinny kind of cosine looking curve. Okay, let's move over here. Ah. All right, I look and I see, okay, I have a sine curve. The first thing I notice is that this is going to shift up 3 units. So it's a sine curve that starts at the x-axis. When I go to graph the original, I'll graph this one for you guys. My amplitude is 2. The highest it goes is positive 2. The lowest it goes is -2. My time period is going to be 2 pi over 1, which is 2 pi. Does this graph go left and right at all? No, just goes up. So what I'm going to do is I'm going to plot the sine curve without the shift first. So my first point is going to be at the x-axis. Then it's positive, so I'm going to go up to pi over 2. Down to the x-axis, down to -2, and then here. So here's my normal little sine curve without the shift. Now, what you guys would look at is all 3 of these points should be shifted. I'm sorry, all of these points should be shifted up 3 units. So 1, 2, 3, here's 1. 1, 2, 2 here. 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 And here. So your answer that you would be looking for is this one. But you notice from the beginning, you can look and say, okay, the amplitude of 2. Do you guys see how the highest this goes and the lowest this goes is 2 units the whole way? It's 2 units the whole way. Right? It's just a sine curve. It started here at the x-axis, we'd like to say, not at the amplitude. And it's a normal shift. I mean, it's a normal sine curve that just shifted up 3 units. You guys have to be able to recognize that. Here, same thing. I'll do this one for you too. There's a lot going on here. This is a reflection. All right, so we're going to say reflection. This is the amplitude. This is my time period, so 2 pi over 2. The time period is just simply pi. And where did this graph shift? It shifted down 2. So if you're still having an issue finding those pieces in between, in between your tick marks in between. I understand that. Okay, this graph is only going from 0 to pi. So this is going to be, and that's it. Each piece is pi over 4. So this is pi over 4. This is 2 pi over 4. This is 3 pi over 4. And this is 4 pi over 4. So I'm going to do this in pieces. I'm going to graph this sine. Okay, my amplitude is 5. So 5 and 5. And I'm going to do the reflection, and then I'll do the vertical shift in a second. So the first thing I'm going to do is it's a sine curve, so it starts at the x-axis. But in this case, instead of going up, it's going to go down to -5. Then here, then up here, then here. So this is what your sine curve looks like. This is what your sine curve looks like without the shift. All right, and this shift is actually 2 units, and it's 2 units down. So this point comes here. This point would come here. This point here. This point would be here, and this one would be here. So your graph looks something like this. Now, the way that you would pick that out is you would say, oh, okay, look, it's a reflection. It starts at the point, whatever it starts at, and it goes down instead of going up. If you notice the amplitude, the whole time is 5 units. From here to here, 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 5 units. And it shifted down too. So you guys need to be able to recognize all those things. And again, this is how you would show me your work. You guys have to show some sort of work. So by pointing the attributes out in the graph, you would be able to show me your work. All right, let's do this last one. This is a reflection. I'll graph this one too for you. This is a reflection. All right. I notice here, there's 2 shifts here. This is going to go right pi units, and it's also going to go up 1. So you could look at your answer choices and say, okay, which graph so far do I have that is a cosine? That means it's going to start at amplitude. It's going to start at the amplitude of 1. All right, and it's going to go down and then back up, and then down and then back up. And it's also shifted up 1 unit. So the whole time period that we're talking about is still 2 pi. So it's from 0 to 2 pi. Okay, if I'm going to move right pi units, that means everything is going to be shifted over. So it's going to start somewhere like here. Right, at -1, but it's going to be shifted over pi units. So then that means my graph is going to look something like this. It's going to start at -1, and then it's going to go up to the x-axis, and then up here, and then here, and then here. So if you notice, it's your normal cosine curve that's reflected, but it's shifted over pi units. But it also has a vertical shift of up 1. So everything would be shifted up 1 unit. So this is what your answer would look like. And you can tell that my amplitude of 1, it's negative, so, oh, I didn't go down. No, I didn't. Yeah, no, we're good. That's fine. So I shifted my graph up 1. It's over the time period of 2 pi. You can see that I shifted it to the right. All of those things you should be able to recognize just by looking at your graph and identifying all the attributes of your graph. So if you guys have any questions, any last minute things, you can ask me on Friday. Again, you're going to have law of cosines questions, which you can have the law of cosines formula and everything on your desk. And you can have, these little notes about amplitude, time period, all that stuff. You have to be able to identify the things in the graph and then match the graph to the correct answer choice. All right. I hope you guys have a nice rest of the week, and we'll see you on Friday.